We live repeatedly doing almost the same routine every day. Wake up, eat, take a bath, run or walk, take a ride to work or school, eat again, sleep, and repeat cycle. These are just some of the general things we often do. But did you know that each of these things has its own scientific explanation? These can be applied to one branch of science, which is physics. And in almost everything we do and encounter, there is physics. Simply pushing a table or leaning behind a wall involves physics. If you have a doubt about this, let's go through a short exploration in our daily living and classify which concept of physics is applied. When it comes to physics, there is a difference between running in a straight line and running with a direction. And here is where speed and velocity enters. Speed and velocity is under the concept of motion. Speed basically describes how fast a system moves, while velocity tells which direction the system is going, just like this example. Running in a straight line can be classified as speed, while running in this way is velocity, because there is a direction. Technically, speed is measured by using this formula. Velocity, on the other hand, takes into account the displacement. If you have trouble with differentiating the two, speed only shows the numerical value, while velocity includes both the magnitude and direction. Can you tell which is speed and which is velocity in this example? You're right! 17 kilometers per hour is speed, while 17 kilometers per hour north is velocity.
There are a lot of things happening in our world. Objects move, fall, and rest all around us. You may think you understand why things move or don't move. But did you know that the forces acting on these objects can be measured? Plus, their motion can be predicted. These three laws of motion are still used today and can help us understand the relationship between the body and the forces acting on it. The first law of motion states that an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an outside force. You have experienced the first law of motion if you have used to swing on the playground. In order to swing, you have to use a lot of force, but once you get going, it can be hard to stop. Another is, as a jeepney moves, it will continue moving unless the driver hits the brake. Here's the time where the jeepney will turn into a stop and will stay at rest. The second law of motion explains that force is the product of mass and acceleration. To make something accelerate, you have to apply force. A motorbike with no passenger and another motorbike with 2 passengers. Which motorcycle will reach the finish line first? Let's see. The motorcycle which is way lighter reach first than the motorcycle with heavier loads. So in this law of acceleration, mass is taken into consideration along with the force. The third law of motion is action-reaction, which states, for every action, there is an equal and opposite reaction. A good example that explains this third law of motion is this. An explanation to this is that the cyclist pedals, then the wheels tend to go forward. The ground then pushes an equal backward force to the wheels. What is tension? Is it the feeling when you're upstage? That's not what I mean. Here are some students playing tug of war. Obviously, force is being exerted on both ends of the rope by means of pulling in opposite direction, and this force is called tension. Can we consider this, fellas? Riding a swing as an application of the principle of tension? You're right. Again, there is a force acting on both ends from where the rope is tied.
We're down to work, energy, and power. How do you define work? If you're thinking work is another term for a job, in physics, work involves a force exerted with a given distance covered. For instance, this situation falls under the concept of work because a force is needed to pull a wheelchair with a patient. Another is there's a distance covered upon pushing the system.
Let's proceed with energy. There's no single definition of energy. In daily usage, energy refers to the sources of fuel. But we often say, we need energy to continue our daily activities. Therefore, energy is the ability to do work. Energy has two types: potential, or the energy at rest, and kinetic, or the energy of motion. How is energy applied in this situation? Gravitational potential energy is possessed when this guy tries to jump from the trunk of a tree. He then gained the kinetic energy while jumping off the tree. Another concept in line with work is power. Power is the rate of doing work. We all know that rate involves time to be measured, hence, power is measured using this formula. Measuring the time of going upstairs in a normal speed versus the time of going upstairs at a faster rate definitely applies the principles of power.
Heat and temperature are two relative concepts in which heat literally talks about hotness of an object or matter, and temperature indicates how hot or cold something is. Temperature is quantitatively measured. Units of measurement for temperature includes degrees Celsius, degrees Fahrenheit, and Kelvin.
Let us try first to convert degrees Celsius into degrees Fahrenheit. So, the formula in finding the degrees Fahrenheit from degrees Celsius is degrees Fahrenheit is equal to 9 over 5. Multiplied by the quantity of a degree Celsius plus 32. So let us have an example in order for us to get a clearer view of this. Let us try 9 over 5. Let us have an example of 37 degrees Celsius. Plus 32. So after computing it, we will come up with the result of 98.6. That is the equivalent of 37 degrees Celsius into Fahrenheit. Now let us try to convert degrees Fahrenheit to degrees Celsius. The formula in finding the degrees Celsius from the degrees Fahrenheit is degrees Celsius is equal to 5 over 9 multiplied by the quantity of the degrees Fahrenheit minus 32. Let us try to have an example. 5/9 multiplied by, let us have 89 degrees Fahrenheit minus 32. After computing it, the result would be 31.67. That is the equivalent of 89 degrees Fahrenheit into degrees Celsius.
See? Physics is really everywhere. Every single thing we do, a concept of motion is applied. Thanks for watching.